So we were studying about the pressure and force, right? So as we know, pressure is equal to force upon area, right? So this is the formula, right? So pressure equal to force upon area. So it can be written as F by A. So what will be the unit of pressure? Force unit is Newton, area unit is meter square. So unit will be Newton per meter square, right? So when the surface area is in contact is a small, pressure acting on the body is small because pressure is inversely proportional to area, right? So when area is small, pressure will be large. And when pressure is inversely proportional to area, when area is large, pressure will be small because they are inversely proportional to each other. So look at the second point. When the surface area in contact is large, pressure acting on the body is small. Therefore, force remaining constant, pressure acting on body varies inversely as the area in contact. So this is the main point which gives the relation between pressure and area. Now next topic is thrust and pressure. So here it is defined thrust. Total force acting on normal direction over a given surface is called thrust. Right? Thrust is the normal force acting on a given surface. Okay? So thrust is nothing but it is a force. And pressure, the thrust acting per unit area of the surface is called pressure. So as we know, pressure is force upon area. So force is called sometimes thrust over a given surface area. Pressure is a scalar quantity. SI unit of pressure will be Newton per meter square. So this is the unit for the pressure. Note the word pressure should be used only for force acting normally, for thrust only. Force acting at an angle doesn't exert pressure on the surface. So when we are applying force, making an angle, that time it is not called pressure. Now look at the examples given below here. Drive a nail into each corner of a small board. Suppose there is a board and put 4 nails on it. Then put the board on sand with the nail heads and downward and press it down with a weight. So the nail head penetrate into the sand very slightly. Right. Then turn the board over and put it on the sand and nail head upward. In this case, supporting area becomes smaller. Nails sink much deeper into the sand under the action of the same force. Right. Thus, result of the action of the force depends on the value of the force acting on each unit of the surface area. So force, when we are applying, it depends on the surface area, right? It means. In the example, consider the force acted at an right angle to the surface of the body. The weight of the body was perpendicular to the surface of the sand. It means force always acts perpendicular to the surface area, right? So both are perpendicular to each other, then only it will act as a thrust. So your next point is total force acting normally on the surface is called thrust. So this is the main definition. So it is only the thrust which is responsible for exerting pressure on the surface, right? Because force acting normally to the surface area. So pressure is the quantity equal to the ratio of the force acting at right angle to the surface to the area of right that surface. To determine the pressure, divide the force acting at right angle to the surface by the area of the surface. That will give you the pressure. So this is the expression for pressure. Pressure is force upon area. So P is the pressure where F represents force acting on the surface area 90 degree. Thus, if the force is constant, then pressure is inversely proportional to the surface area in contact, right? As we know that pressure is inversely proportional to area now. So when area is large, pressure will be small, and when area is small, pressure will be large. So they are inversely proportional to each other. So look at the case one. Block of mass 10 Newton stands with the side of dimension 5 into 5 centimeter 10 centimeter in contact with the surface. So its area will be 5 into 10 raised to minus 2 into 10 raised to minus 2. So area is converted into meter. So it will be equal to 5 into 10 raised to minus 3 meter square. So pressure is thrust upon area. So thrust value is 10 and area is 5 into 10 raised to minus 3. So you will get 10 Newton, right? So its final answer will be 2 into 10 raised to 3 Newton per meter square. Because similarly, when we change the dimension of the block to the 5 into 20, then its area will be changed. So it will be 5 into 20 into 10 raised to minus 4. So it will be 10 raised to minus 2 meter square. So pressure will be thrust upon area. Thrust is constant 10. Area is 10 raised to minus 2. So your pressure will be 1000 Newton meter square. Right. This is the two case which is given for the same thrust. Look at the next point then. A smaller the area of the surface on which force acts, larger will be the pressure. Right. This is the same point which I have explained earlier. Larger the surface area of the force acts, a smaller will be the pressure. So as we know, pressure is inversely proportional to area. So when area is small, pressure will be large, and pressure is inversely proportional to area. And when area is large, pressure will be small because they are inversely proportional to each other. So at a given body may produce different pressure depending on the position, right? Consider a block of dimension 5 into 10 into 20 having a mass of 1 kg. Thrust due to the block on the surface in contact is weight in both the cases, but the same block exert a greater pressure when standing on it, right? And while lying flat on the other side. So this is the two dimension we have considered in the two cases now. So we are getting the different value of pressure when we are applying the same force. So our next topic is pressure in liquids. So it is given by Pascal's law. So pressure exerted at any point in an enclosed liquid is transmitted equally in all directions, right? Suppose this is a tube in which we are applying pressure here. So this pressure is transmitted all over this sphere, right? Equally in all directions. So this is called Pascal's law. So look at the next point. Liquids and gases both flow when a force acts on them. So they are known as fluids. Fluid lack a definite shape of their own and take upon the shape of another container in which they are enclosed. Right. Next point is understanding Pascal's law. French scientist name is Blaise Pascal, while studying the behavior of water as an incompressible liquid, the liquid which is not compressed, discovered that in a fluid at rest, the pressure applied at any point in the enclosed liquid is transmitted equally in all directions, right? So Pascal states that suppose a sphere is there in which water is filled, it is filled with the water, and when we are applying the pressure, the effect of this pressure will be transmitted in all directions of this container. So in practical terms, this finding explains why a teeny glass bottle filled with water breaks when the cork is pushed down, right? So now we'll see about the application of Pascal's law. So this is the main statement for Pascal law. Pressure is exerted in any point enclosed liquid is transmitted equally in all directions. This is called Pascal's law. Now look at the application of Pascal's law. So Pascal law is used in hydraulic brakes, right? Hydraulic elevator, hydraulic press, hydraulic jacks, vacuum pump, air compressor. So these are the applications of Pascal's law, right? So in these devices, pressure on the fluid in them is increased at one point and fluid carries the pressure increases to all other points on the machine, right? So pressure is applied at one point and effect of that is seen all over the container on or the machine. So your first point is hydraulic brakes. The force applied to the brake pedal is transmitted to the wheel by the brake fluid. Next one is hydraulic press. It consists of a cylinder that contains two pistons, one is smaller than the other. So cylinder is filled with the fluid. The force applied to the smaller piston is transmitted over through the liquid to the larger piston, right? So when a small force is applied to the smaller piston, that will provide the same pressure on the other side of the larger piston, right? So this is the main application of Pascal's law. So next point is force increases in direction proportional to the area of the larger piston, right? Look at this experiment. The above experiment demonstrates the Pascal law. The flask with a number of side tube is fitted with the airtight piston and then filled with water. Initially, the level of water in all the side tube is the same, since the liquid finds its own level and rises to the same height in each tube. When the piston is pulled down through some distance, the force is applied at any point on the water. Level of water is seen to rise through the same height in each side. This happens because pressure applied at one place in the liquid is transmitted equally to every parts of the fluid, right? So this is the main application of Pascal's law. So this can be asked in your examination. What is the application? So your answer should be hydraulic brake, hydraulic elevator, hydraulic press, hydraulic jacks, vacuum pump, air compressor. So this is the main diagram given to you. Force increases in direction proportional to the area of the larger piston to the area of the smaller piston. So this is the small area. Here we are applying the force, right? And through the liquid, pressure is transmitted to the larger area, right? So pressure, as we know, pressure is equal to force upon area. So force is written here W1 weight. So W1 upon A1 and P2 is W2 upon A2. So as we know, pressure is equal in all the direction. So we can replace P1 equal to P2. So right here W1 by A1 equal to W2 by A2. So in this way you can get the value of W2 by using this, right? So this is the application of hydraulic press. And this is the main diagram for hydraulic brakes or hydraulic elevator. So we apply the force on a smaller area and we can lift the larger objects on the other side. This is the main application of Pascal's law. Now look at the experimenting with the Pascal principles. So here plunger pressed down, right? So icing syringe filling with the water and plastic tube filled with the water and plungers move out. So we are moving here out and we are inserting here, right? So this experiment show how hydraulic system like water breaks walk, right? Filling one ice syringe with the water, insert its nozzle into the plastic tube. Press the syringe to fill the tube with water. Half fill the second syringe with the water and fix it to the other end of the tube. So that there are no air bubbles inside the tube and syringe. Press one plunger in and you will see that plungers in the other side moves out. So force is transmitted in through this tube, right? because we are applying force here. So this will transmit it to the other side, right? So this is the main principle of Pascal's law. So in this way, we can say that liquid is transmitted in all direction, right? So read once, then we will move ahead. Now look at the next point, pressure inside a liquid at rest. So pressure inside a liquid increases with the depth. So carry out this simple experiment. Procedure, take a 2 liter plastic bottle, okay, and purchase 3 holes with a nail at the 3 different level. Mark the hole ABC. Place the bottle in a tray. Cover the holes with your finger. Ask a friend to fill up the bottle with water. Now remove your finger. Observation will be water flow out feebly from hole A and water shoots out further from the hole B and jets from the hole C is the longest and the strongest, right? So due to the Pascal's law, this will happen, right? So you can see the diagram. I will scroll down here, right? So you can see there are 3 marks ABC in which water is coming out. So your conclusion will be pressing acting at point C is the maximum. Pressure at the point C is the maximum and minimum at the point A. So this will show the minimum pressure and this will show the maximum pressure, right? So this demonstrates that pressure in a liquid is not the same throughout the bulk, but it increases with the depth. So we can say that pressure will be directly proportional to H. Larger will be the H, pressure will be larger. So we can write pressure equal to rho GH. So it depends on the depth, right? Since water pressure increases with the depth, dam which stores water for the consumption and hydroelectric power must be thicker at the base, right? Or curved to spread the load. That's why base is made thick now, because at the depth pressure is more due to liquid. So in this experiment, we can see that pressure at different level will be different. So maximum pressure is seen by PC, then BA, PA, and PA. So PA will be a small as compared to C and B. So this is the main conclusion. Your next point is measurement of pressure. So pressure can be measured using a simple device called manometer. So it consists of glass U tube mounted against a scale or on a vertical board. So U tube contain a suitable liquid like colored water or mercury. So one end of the tube is open and other is connected to the rubber tube. So a thistle funnel with the rubber membrane stretched across the wider mouth is attached to the tube. So initially, the level of liquid in 2 arms of the U-tube is same. If the membrane is pressed, it results in changing in the level of the liquid in the 2 arms U-tube and difference in the level effect of the pressure. So measurement of the pressure is calculated by.
So I don't understand.
Okay, then I will explain you once again. So
Yes.
so instrument name is manometer. This is the shape of U-tube. So it will look like U, right? So U will contain a suitable liquid with colored water or mercury. So U will be filled with the mercury or another liquid having another color like yellow, pink, red, like that. So one end of the tube is open. So another tube, one end of U tube is open and other will be the connected to the rubber tube. So thistle funnel with the rubber membrane stretched across the wider mouth and attached to the tube. I will explain it to the diagram. Let me show you. So you can see here So this is U tube, right? This is the tube which is made in the shape of U, right? This is the rise in the level, right? And this side is connected with the one tube to the Thistle funnel, right? This is the rubber tube in which force is applied, right? So when we are applying the force, so rise of the liquid will increase from like 50 to 60, right? So this is made with the U tube and this side is connected to the Thistle funnel, right? And liquid is filled in this container. And when pressure is applied from the bottom, so rise of the liquid will shown on the other side. So this is called manometer. So this is the main instrument which is used for the measurement of the pressure. You can see initially the level of liquid in the two arms of the U tube is same. So this is your first arm, this one is second arms, right? In which liquid is filled, right? I have taken a tube and its shape is made on the U, like this U, right? I am filling the water here. So this level 1 and this level is 2. So both are equal at a point, right? So if the membrane is pressed, suppose I am pressing here. So this liquid will rise here now due to
Yes, sir.
right? I have told you Pascal's law before now. So when pressure is applied on the other side, so force is experienced on the other side. So when we are pressing here, so liquid will rise here, right? So if the membrane is pressed, it results in the change in the level of the liquid on the two arms of the U tube. So difference in the level indicates the effect of pressure, right? So suppose initially you have filled the water like up to here, right? This side. On the second side, you have filled the water up to this point, and here you have filled up to this point, right? And when we are pressing, applying force here, so this will liquid rise up to this point. Suppose it is coming from here to here. So this difference will give you the pressure, right? So in this way, we can measure the pressure present on the liquid. This is called manometer. So manometer is nothing, it is a U tube shape, U tube shape, right? In which liquid is filled or mercury is filled. Now look at the next point then. Next point is, your next point is, first point I have explained now, second point. So look at the second point. So pressure at a point in a liquid depends upon the density of the liquid, right? So pressure is directly proportional to density. This is the first point. So liquid having a higher density exert a greater pressure, right? So liquid of different density will have different pressure, right? Because it depends on the density of the liquid. So next point is pressure at any point inside a liquid equals in all directions. So when we are applying the pressure to the liquid, so it will transmit the pressure in all directions, right? So this is the third point. Next is pressure at any point in a liquid is same at all points in the horizontal plane, right? Suppose I have taken a U tube. This is a point 1, this is a point 2. So these 2 points are lying in a horizontal plane. So these point A and B having the horizontal pressure, right? Because they are on the same horizontal tracks. So if there were not so, that is if the pressure were greater in one direction, the liquid would flow towards that area. If it is not so now, then liquid will flow from point 1 to point 2. If it is not so, right? Due to the difference in the pressure. So now look at the expression for pressure in a liquid. So base of the container is A, supports the weight of liquid having height h, right? So volume of the container will be area into height. So as we know, pressure is force upon area. So force is represented by mg. Mg is also called weight. So put here in this equation. So it will be force is mg, and as we know, density is equal to mass upon volume. So mass is represented by density into volume. So here we have replaced mass with the volume into density, multiply with the g, acceleration due to gravity, by A. Now put the value of volume. So we know volume is area into height. So this area and this area will get cancelled. So your final expression will be area equal to h, b and g. B is the density, right? And h is the height of the container, and g is the acceleration due to gravity. So this is the another expression for the pressure when liquid is in the container. So write the expression. Look at the next point. A liquid sink its own level. So water is filled in a series of interconnected vessel of the different shape. So we have taken the different container of the different shape. It is seen that water stands at the same horizontal level in each case. So regardless of the shape. So this principle explains why water reservoirs are generally located at higher level, and why the water tank in all the buildings are placed at the top of the building rather than the bottom, right? Because pressure depends on the height now. So when we want more pressure, we keep the tank on the height. That will give you the more pressure, right? Pressure is directly proportional to height. Next point is make a water fountain. This activity is based on the principle that water seeks out on level. So a perforated shower head is held at the level below the water reservoir. Water passes through the rubber tube and jets out through the shower head to reach level of the water in the tank, giving the appearance of the fountain. So here water is reserved and we are getting a spring water, right? This is the shower head. So in shower, water is coming like this now due to the pressure, because this water tank is kept on the height. Okay. So this is the main property. Next point is fluid pressure and force. So consider a tank partially filled with the water. So this is the tank in which water is filled up to this point at height h, right? So length of this tank, this is the breadth. So as we know, pressure is rho gh or hdg, right? So if the height of the water is 3 meter and its density 1000 kg per meter cube, so we are exerting this much amount of pressure, right? Now, if the total force or thrust on the bottom of the tank to be known, then the force or weight entire of the liquid should be calculated. So force will be mg. So we put m instead of m, volume into density. So it will be coming out. So it will be this one. Area into height into d into g. So put the value of area, length into width and height, you will get this much amount of force, right? So basically we have put the value and calculated the pressure for a fixed dimension. So this much amount of force will be coming out. 2,35, 200 Newton, right? 2,35,200 Newton. Okay, we have put the all the value. Length, width, height, and density and G. So this much amount of force acting on the downward of the bottom.
Please, may I go to the washroom?
Okay. Next point is pressure and force. So it must be emphasized that pressure is not same as force. So when pressure is the ratio of force per unit area, but force is the product of pressure and area. So P is F by A. Now cross multiply. So F will be P into A. So this is the different quantities force and pressure. So fluid pressure and shape containing of the container. So fluid exert pressure against any surface that it comes in contact with it. So when a fluid is contained in a vessel, it exerts a pressure on the base of the container, and this pressure is not affected by the shape or size of the container. So it simply is the experiment shows verify this statement. So it doesn't depends on the shape and size of the container. So it depends on the only liquids, right? That's all for today.